and get done quicker, but you can't. You really can't. You'd have to be able to hold a lot in your head. You can't multiply, because this m could go to that m, or to that 5, or to that m, and that, or these two m's could go to that m, or to that 5. Oh, no, thank you. Can you start to see what I'm talking about? So a few of you guys didn't do as many multiplications as you should have. You tried to do everything at once, and that is next to impossible. I'd much rather do these two first. Have this guy come for the ride for a second, which is how we do it with numbers. I gave you the example, how would you do 4 times 5 times 7? What would you do? Would you do all three at once? I don't even know how to do that. You'd say 4 times 5 and get an answer, and then do 20 times 7, right? I like it. So we're going to do the same thing. What is this? This is 3 numbers, I don't know, but they have to act like any other numbers. I'm going to multiply the first 2, get something, and then multiply by the last 2. Right? I can't do it. It's a little worse than this. Why do I think I should be able to do it quicker than this? I can't. So what do you get when you multiply this?
16.
Minus 5m. Minus 5m. Plus 25, I love it. So you get m squared minus 10m plus 25. And then you just have to distribute, get your like terms together. Right? Now please realize that is not a long problem. That is not. Just because there's more than 1 or 2 steps does not make it a long problem. So don't think that. I might be tempted to give you an actual long problem. I don't think you want me to do that. So here you would just take the m squared through.
Does that make it m3?
Good. M cubed.
Cubed.
5m.
Minus 5m squared. Right, now he gets a turn. Minus 10m squared, I love it. M is m squared. Negative 10 times negative 5 is 50. 50m. And now he gets his turn. 25m. I love it.
Okay.
And now you just got to get your like terms together. All right. So a lot of these problems, your last step is get like terms together. Because now you've freed everybody up. Up here, that m can't go with him and that 5 can't go. The minute you've done multiplying, you've freed everybody up. They can all move wherever the hell they want to. In fact, they don't have to move very far because these two are sitting next to each other. These two are sitting next to each other. That kicks ass, right? Those are like terms. Those are like terms. So I get m cubed. You trying to learn what the sign is for ass?
I already did it, so yeah, I was.
Okay. M cubed. And then
negative 15m squared.
15m squared.
Plus 20, 75m.
75m. Minus 125. Cool. Now, I will understand that you understand there's very little way to check your work here. How do you check your work? You do it again. Or the only real way you can check your work is to plug a number in here, do it, and see if you get the same thing here. Sort of like what I was doing on the Jeff's side notes.
Oh, like
so if you put a 3 in there, 3 minus 5 is negative 2 cubed is negative 8. If you put a 3 in there, you better still get negative 8. But you can see how that in itself is kind of a long process. So I might just want to say, I think it's okay. But notice one thing. M should be cubed. There should be an m cubed in there. Because at some point you got to do m cubed. And at some point you're going to have 3 negative 5s. So they should be in there. This stuff is from the cross multiplying, right? The little in-between stuff. But at least I see m cubed. That makes sense because I have an m something that's being cubed. Cool. And I see my 125 because there's a 5 in there being cubed. Okay. You just can't do this. No. You've lost all this middle stuff. Okay, cool. Okay.
Yes.
So what next? What do we want to look at next? Do we want to do?
Now you didn't want us to do 7 and 10 on that one. Should we be able to do that now?
Oh yeah. So looking back at the, if you have this with you today, oops, where's mine? Too much paper. This one that we did last time, we all kind of worked on it. Like I said, I have the answers here today, so I'll give that to you in a minute. We can try to do number 7 and 10 now. We skipped those last time because I didn't talk about cubes until after we did this. So I'll put them up here on the board in case you didn't bring this here. So try to do these two. And then I'll give you guys the answer key for that. So this is going to be cool. I'll keep it with you because I'm going to give the answer here. So you can just check yourself. Just make sure everybody's on the right track. Who remembers what the very first step is? Somebody humor me.
Greatest common factor?
Well, okay, GCF. Is there a GCF? No. So it's a good point, though. You always try GCF. But then you see it's two terms. You know it could be a cubes or a squares. It's obviously a cubes because there's a third power there. And everything else can be broken into three parts. Well, what do you put down here? Humor me. Little dude. Big dude. All right. 64 is 4. You with me?
Yeah.
4. 27W cubed would be 3W. All right, go ahead and finish it out if you haven't finished it out yet. Just want to make sure you got the first couple steps right.
So when you're trying to figure this out, figure out the factors of those each numbers. And it's always going to have three terms. There's always going to be a bigger part, and then times by binomial like that. It's always going to be.
It's always going to have that format. If it's a difference of cubes, it's always going to have a little dude, big dude. Cool.
Sounds silly.
I kind of do that on purpose because I think it might stick in your head better if I say something like little dude, big dude.
No, it works.
Okay, cool.
I forgot how to get the middle one.
Other than trinomial. All right, so what goes in the little dude? 1, 4, because he's a little dude. You can only take one of each. Minus 3W, one of those. So one of each goes in here. So of course, how many of each have to go over there? 2. So what goes here?
16.
16. So there's your 64. What goes at the end?
9W squared.
9W squared. So there's your minus 27W cubed. And we talked the other day about, well, I don't want this and I don't want that. So this guy comes in and cleans it up for me, right? That's why there's a little dude, big dude. One of each, 2 of each. Why do I need a big dude? So I can have the cancellation part in the middle there. So what sign is he going to have? It's going to be plus. Obviously, he's got to be cancellation dude. He's got to be the opposite sign. Kind of makes sense?
So to do.
12W. I love it.
Oh.
It's always, the middle guy is always this times this. Bam. Always. Whatever the hell is here, whatever the hell's there, you multiply them, you put them right in the middle.
So, and you know it's addition because that's like minus 3W. Like you know to add the 12W.
Yeah, since this minus that has to have the opposite sign because he is the cancellation dude.
Okay.
Right?
Yeah.
Lots of dudes. within dudes. It's kind of weird. So what about this guy? Try him if you haven't done that one yet. What you talking about today in that? I'm not really sure.
Little dudes going.
Little and big dudes doing things. I don't know, Mom. Kind of weird.
I will tell you.
All right.
Oh wait.
How do you know what sign to put in the little dude?
Say again.
How do you know what sign to put in the little dude?
Same as the original.
Okay.
So if that would have been a plus, that would have been a plus, and that would have to be a minus.
Oh. Taco Bell. That's what I say when the phone rings at Denny's.
I don't speak that. Sorry. I wish I could.
What is 2 minus 3?
2 minus 3.
So t cubed obviously is t. 27 is 3. Little dude, big dude, because it's a cubes. Yeah, so sounds like a shuttle launch. So I got to put 1t, t minus 3, and counting. So what goes here? The other 2 t's, so I get 3 altogether. Bam.
It doesn't matter if you put the 3 minus t.
Wait, is that
It does matter.
It does?
Yes.
Is that a T
They're
right there?
both that. Yes, they're both T. T cubed.
Okay, it just looked
Alright,
really.
cool. And what goes here at the end?
9.
9. And then what sign has to be here? Plus
3t.
3t. Middle term is the product of these two. Different sign. So the only difference, if this would have been a plus, this would have been a plus, and this would have been a minus. You see that? So if this would have been a plus, this would have been a plus, this would have been a minus. Little dude always the same sign. This guy's always the opposite of him. So there's always only one negative in the whole thing. It's either there or there. You guys see that?
And the second sign is always a plus.
That last
Plus
dude, the
9.
last sign. Always a plus, because if I need a minus and that's a minus, I don't want that to be a minus 2 or else it comes out positive, right? So he's always plus because the sign is already determined there. Okay, good. I like it. Yeah, I'm going to give you one more like that, and then I'll give you the answer for this.
Okay. Good boss.
Let me give you one. Yes, 6-4.
We're being tested on 6-4.
Oh yes.
Is that the last section in 6-4?
It's there's one more section in chapter 6 that we'll talk about after the next test. Yeah. So this test is going to go up through 6-4 because we didn't get to 6-5 last time. No, it's factorable.
Huh?
So let's see. There's 2 terms. You can only be squares or cubes, right? 2 terms means squares or cubes. GCF, there's no GCF, so we can just kind of continue past that. What's 125? 555, and then you each get a y, so it'll be 5y, 5y, 5y. Is that cool? And 8
2.
is 2, so it'll be 2,
2W.
2w, 2w, 2w. Become a w. So now you can populate your little dude and your big dude, right? What goes in the little dude?
5.
15y
Plus.
plus, good, 1, 2w. So since I put 1 of each there, I've got to put 2 of each there, so overall I end up with 3 of each. So the basic idea is almost like, well, duh, Jeff. If you put 1 there, you got to put 2 there, so you get 3 over here. So what's got to go here?
15y squared.
The other two 5y's, which makes 25y squared, I love it. Here,
10w.
the other two w's, which makes 4w squared. What sign in the middle?
Negative
Minus,
Wait, how did you know which
10
cool, or 10yw is fine. I just put in alphabetical order. Say again, sorry?
So that, the only negative sign, like, only the middle term is gonna be the.
In this case. Because he's the same as this one, and that's got to be the opposite of that one.
That's around this.
Cool.
Yeah.
This is only what's written for test.
Yep. Let me follow it up with that. How would you do that one?
Yeah. You just have to take out everything that you can first. So like that one here,
5 minus 4 delta is 5 minus 4 delta.
Almost.
You
25 is 5 and 5. Minus plus. 4 is 2, so 2w. 2w. But do you guys see the similarities? Here there's 2 of each, so I put 1 there, 1 there, 1 there, 1 there. So there's 2 overall. Here there's 3 of each, so I put 1 there, 2 there. 1 of them there, the other 2 of them there. This is a little more complicated though, because once you do that, you got all these cross terms, these little middle terms you don't want. So that's why we need an extra guy here. I'm hopeful. All right, this is what we call a what? What is this?
Negative.
What type of thing is this? Difference of squares. Cool. Right? Or I would have accepted a thank God problem.
Oh yeah.
Because they are simple. Don't make more of them than they are. It's all about identifying the type of problem you have. The biggest mistakes people make with almost all of mathematics, especially factoring, is they try to use the wrong thing on the wrong problem. So it's just the squares there. It shouldn't be that big of a deal. This is a cubes, a little more complicated. That's the squares. Don't make it any more complicated than that. So let me give you the answer key. And then I'll give you the answer key for the practice test. So I try to be a little explanatory in this every now and again. So try to explain what's going on. Some of them I just did it, but some of them I try to explain the steps. now we can do whatever you guys want to do. We can do some examples from all the sections.
We go way back?
Huh?
We go way back?
Yeah, as far back as the test is going to go.
4.4?
Yes.
Word problem. Number 21 on 4.4.
Oh yeah, okay. This is section 4.4, page 279,
Yeah.
278, number 21. So it says Karen has twice as much money at 5%. What in the world is that? As she does at 4%. If her yearly income from these two investments for interest is $350, how much is in each account? Okay. So they do refer you back to example 2, but example 2 is not really directly about interest problems. Do you guys know how to calculate simple interest if you put $500 in a 5% account? How much you're going to have at the end of the year? That kind of thing. So interest in general is principal, the amount you put in, times rate, times time.
So you have to know this for the problem.
Yeah, so the nice thing about the time is they told us it's 1 year, so I know that T is 1. It's not really going to come into play. So very often what I'll do for this kind of problem is sort of like what they do in this section is I make a little chart to kind of help me organize all this mess. So what two main things do I have going on here? What are the two main parts of this problem?
4% and 5%.
4% and 5%. Now can we agree on which one has more money in it?
The 5%.
How do you know that?
Because it's a bigger.
Because it says so, right? There's twice as much in the 5% as there is in the 4%. So which one of those is going to be just X? Oh, this is linear systems. I can just call them X and Y. So here's the principal. Here's the rate. And if I multiply those, I'm going to get the interest. That's what the formula here says, right? Principal times rate is interest. Okay. We're good so far. So it's all about what are my variables, and then can I set up equations to help me get there. So one equation that I can set up, how much do I have at 4% and how much do I have at 5%?
4% X.
Good, 4% X and we'll solve 5% Y. I like it. There's really no good two letters to use there, so I'll just use X and Y. So one equation I know right off the bat, in a way, is from here. There's twice as much at 5% as there is at 4%.
So 5% wouldn't be 2x?
So good. The amount in the amount in 5% is twice the amount in 4%. I love it. Is that cool so far? So that is an equation that relates how much is the amount equation. Now I need a money equation. So how much is at 4%? How much is in there? 4%? X. How much at 5%? Y.
2x, or no? Okay.
I understand what you're saying, but we're not quite there yet. And then the rate for 4% would be 0.04. So what's the rate for 5%? Make it into a decimal, good. And then I do that percentage of the amount of money, right? I multiply the rate times the amount. So 0.04 times X, 0.04X, 0.05 times Y.
But it tells us that our, no, never mind.
It's okay. Personally, I wouldn't do this problem using two variables because of what you just said. They tell me directly that the amount here is twice as much as there. So do I really truly need that Y? No, and you can see that right here. What do we write? Y is 2x. Why don't I just put a 2x there? I agree with you.
Wait, so how can we put the variable, like, on the entrance, how can we put the x and the y under it? Like, what makes that?
So if I had $200 at 5%,
Yeah,
how much would I have interest in a year? 5% of $200.
okay.
So in a year, I'd have 0.05 times 200. I'd have $10 interest.
Okay, so you're just tightening.
So this now is a variable. But I still have to multiply to figure out how much interest I have. So y is the total amount of money I put in. So of course there's going to be 5% of that is going to be my interest.
Okay.
Right? So there's going to be a very small multiplication times
that
this.
whatever the amount.
Yeah.
Okay.
So if I made $350 total interest, if I take the interest I made here and the interest I made there, what has to happen?
You have to get the,
How much total interest did I make? $350. So if I take this interest plus that interest, I better get $350. They told me directly that I made a total of $350 in interest. So now here's one equation, here's the second equation. I would highly recommend substitution method, right? Because they tell me y is 2x. I can just put it right in. So the whole point of section 4.4 was setting up two equations and then using substitution or elimination to solve that bad boy. Some of you guys right now are going, oh yeah, that's right, it's going to be on this test. Yeah.
I asked.
Yes. Okay. That's one of the more involved problems there, is because we don't use this formula very often.
So
We all
is
kind of
there
trust the
gonna be-
bank to do the right thing.
Is there gonna be an interest problem on it?
Could be, because they're in the homework. Yep.
Alright.
Yeah.
Can we do H from the practice test? 1H.
Oh yeah. So 1H is this big mamma jamma thing. Just to bring back a phrase from my youth. People still say mamma jamma?
No.
No? Okay.
No, I wouldn't. Mamma jamma?
No? No more mamma jamma?
No. Sorry.
That's right. It's my own little adjective. Alright. So there's a lot of different ways to work this problem. But when you first see this problem, I almost can't blame you for going, oh God. But again, I keep saying this, the people that do really well with math are the people that are able to break a problem into parts. One part of this is stupid easy. Let me first ask you before we get there, what would I do last? Definitely last. Yeah, the very outside exponent, right? Because order operation says doing the parentheses. So order operation saves my ass on this problem. It helps me out. I would do that thing last. I'm going to forget about him for a minute. Inside, what I mean by breaking it apart, part of this is just the reduction problem right there on numbers. Right? The answer here is not 8. Division is not the same as subtraction. You're thinking about what you do with exponents, and I understand that, but 32 divided by 24 is never and will never be 8.
Do you know what they both go into?
Yeah, you just reduce it like always. That's just a fraction, nothing new. So what goes into both of those?
8.
So it goes down to be 4 over 3. Cool.
Huh? You said it was 8, and then you say it's 4 and 3? I'm confused.
Now I made a big point to say it is definitely not
Not
8. Can you see why somebody might think the answer here would be 8? Because what they do,
Yeah.
They both go into it.
they subtracted 32 minus 24. Why do you think somebody would do that? Because what do I do with the x's?
Subtract.
I subtract the exponents. Are these exponents? No, so they're not going to act like exponents. So what you can do for yourself is cover the damn thing. And that, if I gave you that problem, None of you better miss that damn problem. Just reduce the fraction. And that is a part of this problem, is reduce that fraction. Don't make more of that piece than it is. It's just a fraction. Reduce it. And actually, that's exactly what we're doing the rest of them. How many x's can I cancel here? 10. Just like I canceled an 8 here. So it's all reducing. But if I had 12 x's and I cancel 10 of them, I of course have 2 left. That's why one shortcut is 12 minus 10. Now, looking at the rest of this, my suggestion on how to do this is to flip your negative exponents. I think most of you guys kind of are able to do that. Some of you don't like it. Another way to do it is just to apply the rule directly. But when you do that, you can make negative mistakes very easily. Because what do you do with exponents? You, of course, subtract them here because it's division. You'd have to do -3 minus -5 and not forget that other one. And very often we forget that other one. Right? So I would suggest you do this. And this is good practice for negatives. I already circled 1. That's going to flip. What else is going to flip? The z's. These -6 z's, right? Yeah. What else is going to flip?
Y.
And everything else is going to stay where it is because nobody else is negative power. So that z squared is still there on the bottom, but what's coming down with them? Z6, good. And these 5 y's go up, but these 3 y's come down. Now everything's a positive power. I'm not going to make a negative mistake as I do this problem. This is not the only way to do this problem, but it's my strong recommendation.
Does it matter if it's like if we write 3y squared plus, or next to the z squared, and then 6, or does it matter if they have to be in that order exactly? Okay, sorry.
Okay. So what do you get on the top here? 4x squared. What happens to the y's?
Y.
Yeah, 3 y's cancel, so I am left with a couple up there, right? What happens on the bottom now? How many z's do I get on the bottom? 8, right? I had 2 of them. 6 more came down, so now I have 8 z's down there. And what does that outside power tell me to do?
Plug to the inside.
2 things. Yeah, flip it, and then of course
Distribute it.
square it. I love it. So I do it. Each one at a time, right? I first flip everything. Everything just flips, right? Because what's being raised to a negative power? Everything. So that just straight up flips. But what do I still have to do? I flipped it, but I still have to square it. I haven't done that yet. You guys with me?
So far.
Okay. Because if I have this, what does that become?
1 over m squared.
So the square is still there, but is it still negative?
No.
Why is it not negative anymore? Because you did what the negative wanted you to. You flipped it. So the minute you do what the negative wants you to do, why would he still be there? Otherwise, I would just keep flipping forever, and then I would never get to any other problem. Flip it, no flip it, no flip it, no flip it.
Oh, so you flip the whole entire thing. I see.
Yeah, so I did what the negative told me to do. Why would he still be there? Right? Or else you'll be in a little padded room for the rest of your life, flipping this forever. That would suck. So here now I can square it. What do I get when I square everything? 9. Z to the 16, good, not 64. I'm not squaring 8, I'm squaring z to the 8th. A couple z to the 8th is z to the 16th. You multiply exponents when you raise them. Sure enough.
Wait.
Now let me show you something. Let me get you guys to really be with me on this. What's the power on the 3?
3 times.
What's the power on the 3 right now, just by itself in there?
1.
A 1. That is why it becomes 3 to the
Third.
1.
2.
3 squared.
Third.
Right? Because what do you do with exponents? You multiply them. So I am not treating the numbers any differently than the letters. It's just that with numbers, I can actually go the next step. 3 squared, I know that's 9. M squared, I don't know what the hell that is. So people feel like we do different things that no, we don't. We never do. If it has exponents, I multiply those. If it's a number, I can actually take it one step further. We normally skip this step, don't we? I don't see people write this down. They know 3 squared is 9. But it's because you're doing the 1 times 2 is 2, and then you can do 3 squared is 9. So 8 times 2, 16. 1 times 2, so I get 4 to the second. X to the 4. 2 times 2 is 4, and 2 times 2 is 4. And then I can do 3 squared is 9. Z16 is, I have no idea. 4 squared, 16. X4, Y4, I have no idea. Stop. All I did in the last step was 3 squared and 4 squared. That's it. Just cleaned it up. But that's the biggest problem people have with these is they say, well, why do you multiply that one and you square that one, you know.
Where's the Z6? Is that Z16? Wait, what is that?
So
It's totally a Z16. Because 8 times 2, 16.
Oh, because you added.
Multiply.
Oh, it kind of looks like 97. Kind of.
97? Sorry.
Yeah.
Deal with it. That's my Z. All right.
Oh boy.
Okay.
Now, I want you to realize something, and I think I said this before. That is an uglier problem than I would ever put on the actual test. Okay. Any of you guys play basketball? Even partially. You ever seen the basketballs that are actually a little bigger than a normal basketball? So if you practice with that one and you actually make the shots, then hell yeah, you can make them with a smaller one because now it gets in the freaking hole easier, right? So my practice tests will very often have problems like that one. They're a little bit more than what I'm going to actually give you. Because if you can understand this one, you can definitely understand the smaller ones that I'm going to actually give you in the test. So 1H, I'm not going to give you one quite that loaded. I keep trying to tell you guys that I don't care how much crap is in there, you look at it as separate problems, and each one is not that bad. Reduce, subtract exponents, flip the negative. But we as students, we look at this and we look at it all at once, and we're like, oh crap. Okay. So I'm not going to give you one quite that huge. Any other questions from the practice test or quiz or homework?
Yeah. We do 90 on 5.5.
Oh. I think
Or did you do that one?
I think I looked at that one, yeah.
Or were you trying to move? How about 95? You didn't do that.
Oh, yeah. Okay. This is what I call a cookie cutter problem. Because it looks like somebody has some rectangular dough and then they cut a rectangular cookie out of it. Because the problem says, find the area of the shaded region, right? Find the shaded area or something like that. Yeah. You see this kind of problem all the time on like SAT tests and stuff. Find the shaded area, whatever. So before I cut that piece out, what's the area of that whole piece of dough laying on my thing before I cut that little tiny cookie piece out? What's the area of this whole thing? How do I get the area? Multiply, exactly, right? Area is length times width. So the area of the whole thing equals x plus 7.
Square.
All right, cool. Times x plus 7. So what do you get for the area of the whole thing then? Start doing that for me. Is this cool? Plus 7x plus 7x. Going to go ahead and make that plus 14x?
Yeah.
Can you guys do that? Okay, cool. And then 7, 7, 49. Now, how much am I cutting out? What's the area of the cut? You gotta love this one. X times x, x squared. So now if I take my whole area, my complete dough, now I'm getting hungry for cookies. and then you cut out this cookie. So of course, what is that going to be in math? Minus. If I cut out a piece, it's minus the little cookie piece. All right, let me do this again. So here's my area of my whole dough, right? So I just rolled it out, and somehow it came out to be a square.
Yeah, okay.
And then I cut out the cookie, which in math speak is minus the area of the little cookie.
Okay.
And of course, what do I get then?
14.
Yeah, these pieces cancel. And you get that. So I got that much dough left to work with and make more cookies. Okay, cool. I'm gonna get some cookies in the middle.
So to figure out the area, subtract the little area.
Yeah, to get the shaded region, you get the whole thing, then you subtract from it the piece that you want to cut out. Yeah.
Okay.
So when you first look at that, it might be like, how the hell am I going to do that?
Yeah.
Cover that up, and that's, what's the area of that? That times that. Minus the area that I want you to not include, the area they're going to cut out. So I call that a cookie cutter problem.
That's it?
Yes, that's it. Yeah.
3B?
On the practice test?
Yes.
3B. What's this dude doing? Okay. So the question here, the first question is this a polynomial?
What is this on? Where is this?
3B.
On the practice test?
On practice test. This is definitely a polynomial. Because what are the powers? A third power, a second power, a first power. I don't care about, in fact, I could rewrite this like that, right? It's the same thing. Coefficients could be any numbers they want to be, as long as my variables only have whole number exponents. You can have negative powers. You can't have a variable on the bottom. So when I said there can't be any fractions of variables on the bottom, like that, if I had 1 over b, that's not a polynomial. Because what can b not be? You can't divide by what? What can you not divide by? 0. So can b be 0? No. If it had this, does it have anything like this in it? No. Can b be anything you want it to be? Hell yes. Right? I can cube any number. I can square any number, and I can divide any number by 3. Right? That's really why polynomials are defined the way they are. There are no negative powers in the b's. They're all whole number powers, right? First power there. That is totally a polynomial. Which one of those is not a polynomial? On number 3? C. Yeah, it's got a negative power. Not a polynomial. Don't answer me anything about it then. Don't tell me degree, don't tell me anything. It's not a polynomial. Who cares? But this one is a polynomial. What specific type? I think you said? Trinomial. What degree? Third degree. Third degree trinomial. And what's the leading coefficient? What's the number in front of the largest degree term? What's the largest degree term? Which one?
B3.
So what's the number in front? Understood to be 1. So the leading coefficient is 1. Third degree trinomial. Okay. Again, those are just definitions. They're not the most exciting things in the world. We don't totally understand why all the time, why math people call things certain things. But this is the truth. If I tell a colleague I've got a polynomial I'm working with, my colleague already knows, oh, it's going to look kind of nice. I can put whatever I want to into it. You know, there's nothing that, you can't put a 0 in there. No, I can put whatever the hell I want to into it. It's a very quick way for us to communicate with each other. Okay. So let me give you a little piece of advice. If you're still having trouble with factoring, I would definitely focus on each procedure until you can get the process down, right? So make sure you can do a difference of squares. Knowing it's a difference of squares. Make sure you can do a surefire. Knowing it's that kind of problem, right? But then you want to practice, what if it's all mixed, like it is on the practice test? Because that's the way you're going to get it. It's going to be mixed. Because part of what I have to test you on is, can you identify what kind of problem it is? So in that factory section, number 4. Can anybody tell me on number 4, are there any anything that looks like it might end up being a cubes?
On the practice test?
Yep, on the practice test. To be a cubes, how many terms can you have? 4 terms is what kind of factoring?
Grouping.
Grouping. 3 terms is trial and error or surefire. 2 terms is squares or cubes. So first look and say, anybody have 2 terms?
B.
B and
F.
F. Which one of those looks like it could be a cubes? B, because it's got cubes in it. I love it, right? And more generally, everything, the powers in there can be cut in thirds. But what's wrong with B? Why is it not really a cubes yet?
Why do the 2X?
What's 2? Can you break it into 3 parts?
1? No. I don't know.
No, no, you can't. So I agree with you. I don't know what the hell it is. Cube root of 2. What the hell? I don't know shit. So, but what saves my ass? What do I always try first? GCF. What could come out? 2. And what do you have left over when you take a 2 out?
X3.
X cubed. 27. Hey, cool. And 27 is what?
3.
3, 3, 3. So GCF, sometimes it's the only thing you can do, and sometimes it uncovers something you can do more with. So I took a 2 out of the way, and now, oh shit, I can see the cubes now.
So now how would you do the little kind?
You make a little dude, big dude.
Oh, you just leave the 2 outside?
Yeah, the 2 just comes for the ride.
Okay.
Whatever you already done, it just comes for the ride. Because if I ever leave them off, I'm not right anymore. I can never get back the 2 and the 54. He's just got to come for the ride.
So it becomes X plus 3.
Good, so X cubed, XXX. 27, Y cubed is 3Y, 3Y,
Oh, yeah,
3Y. Right?
Mm-hmm.
This is the process you go through for a cubes. So this is what I mean when you go to study. Make sure you understand the process by itself. So go to the right section and say, okay, here I need to do a cubes. Let me just do several of them. Get the process. Squares, get the process. Surefire, where the first number is not a 1. Get the process down. Then say, let me go and get mixture, right? And you can go to the review section in the book. You can do number 4 problems on the practice test to get a mixture and say, okay, now can I identify what the hell to do when? That, of course, is the hardest thing in math. What the hell do I do when, right? So here, we identified it as 2 terms. The GCF helped me see that it was a cubes. Everything can be broken down into 3 parts. So what goes in the little dude?
X plus 3Y.
Good, X plus
3Y.
3Y. So these 2 have to go here. These 2 have to go, I love it. And the middle dude,
Subtracts.
minus
The 3Xy.
3xy, I love it. Or 3yx, put that, I'm happy. Funny thing is, I think you guys are going to end up being really good at cubes, and maybe sucking in some other ones, I don't know. Because I focused a lot on cubes, but if you do a couple of these, right, not right before the test, but a little bit before the test, just to get the format in your head, that's what I would do if I were you. Because it's a really easy format to kind of like lose. Yeah?
Can you do 4D?
What kind of problem is 4D?
You take it out. Do the GC.
Yeah, it's got 3 terms, so it's possible it's going to be a trial and error or surefire, but it's definitely got loaded with B's and G's, and it's got to be a GCF at least first. So So again, I wonder if anybody notices this. Every time I talk about this, even if I forget to say it, it's all about breaking it into parts. I look at the numbers first, and then I look at each letter as it comes, right? What number can come out of all three numbers? 2. That's pretty easy. How many B's can come out of each one? 1. Because he can only get 1. So they each have at least 1 B. So the biggest mistake I saw people making on the GCF problems on the quiz, they didn't take enough stuff out. If I do a step and I got B's in each one, I can still take a B out. They should not have anything in common when I think I'm done. How many G's can come out? 3. He can give 4, but they can only give 3. So what's left here if I do that?
6.
Good. 6. Had 2, took 1, I got 1. Had 4, took 3, I got 1. How we doing? Good. Plus 5. Had 4, I took 1, I got 3. Had 3, I took them.
Okay. Minus
Now, can I just do that? Yay.
minus 1.
No.
Good. I can't have 3 terms and suddenly only have 2. Right? But it's got to still be 3 terms, and this divided by itself is 1. And I was actually thinking about this earlier. Let me just say this, and if you think it'll help you out, you can do this. I never really teach it like this. I have no idea if anybody ever does. But you identify this is done, by the way. You cool with that? Good stuff. So let me show you maybe if you like this. You identify what comes out. Then you put that under each one, because that's what I'm going to divide it out, right? That's the idea. I'm undistributing, so I'm doing the opposite of distribution. I'm dividing now. So underneath each one. So I don't know if that would help anybody. If that won't help anybody, don't do it. That's great. That's fine. But do you understand what I'm trying to say? This is what you're doing. This is what I'm trying to get you to do in your head, but more talking it out. I had 2 B's, I took 1, I got 1 left. It's not so much math then, it's just how much you got left. But here you can see that's 6, a B cancels, 3 G's cancel. I mean, you can kind of see it happening. So I don't know if that's going to help, if you have any trouble with that, if that might help you out. Okay. By the way, I need to remember, I think Monday I don't have a meeting at 11. So I'm going to try to see if I can have, I'm going to email you guys and my earlier class, because they have a test on Monday also. I'm going to try to see if I can be in there from 11 to my 12:30 class, in case you can come in to my office hours then. So, because the test will be later that day. Yeah?
I just had a question on 1i. When I know that for 0, when it's like the power of 0 equals 1, but on the answer sheet you didn't do anything with the y's or the x's. Does that matter?
So how do you mean? Like anything to a 0 power is
1.
So
the 3y
this
to the
thing
power
to a
of
0 power, this whole thing is to a 0 power, so it becomes 1.
But it's not 1y. Okay.
Anything to a 0 power is
Just 1.
1.
Okay.
Cool. Now over here, what's being raised to a 0 power?
Just the x.
Good.
Right?
So this is still a 4 times 1. I love it.
Oh.
So
The letters don't matter.
sometimes I see somebody tell me this, and I know what they're thinking. They're thinking when I say x to the 0 power is 1, they think I really mean 1x somehow. But think about that. Does that make any sense? You're essentially saying that 0 equals 1, which is kind of hard to digest, right? Plus, you're going to tell me that this would be the same as this, which it obviously isn't. That's x9 and that's x8. So you can see that that acts like a 1, because it didn't affect this, did it?
Okay.
That times this is still x8. So it is a 1. Good. Just be careful about my parenthesis placement, right? It's that same old thing that teachers love, the difference between this and this. That's squaring the negative, so it's going to come out positive. This one is negative 2 squared, which is 4, so it comes out negative. because of the parenthesis placement. In the first one, the negative's being squared, and the second one, it isn't. So it actually is sort of the same problem, sort of the same kind of problem. Cool.
Okay.
So what if watch this. I did this once, and I don't ever do this again, so I don't mind telling you this. I'm not going to do this on the test, because it is kind of evil. But I have been known to do stuff like, I'm not going to do this on this test, I already told you that. And I'll have people do all this work inside.
That's just
Well, what's the answer?
One.
Yeah.
You
Anything
can do that.
anything to the 0 power is 1. Right?
You should do that on
So I don't do that anymore, don't worry.
Wait,
But it'd be
that
fun.
whole thing is one?
Yeah.
What did I just say? This, now, I want you to understand. If I tell you what X, Y, Z, and W are, isn't this a number? This is one thing, you understand? This is one thing. Anything to the 0 power is 1. Bam. Right? So you could do work in here if you wanted to. That's kind of crazy. Because it's all to a 0 power. It's 1. So don't worry, I'm not going to do that to you. Right?
Now, if they have a power to 1, does that just mean everything stays the same?
Everything stays the same, and you just have to reduce things inside. If it's just the first power, there's always an understood first power.
Yeah.
So if I just write it explicitly, you go, well, whatever, Jeff.
Yeah, I don't know.
Because it just means stays the same, yeah.
Yeah, okay.
So, as always, I would highly recommend if you do this practice test and you notice you're having trouble like on number 5, you go back to this section that talks about it. You do maybe some of the odd problems that you didn't do for extra practice, right? You come see me, you go see a tutor. Please come see me. I'm not seeing many people in my office. I know there's more people that need help than 0. So, you guys have anywhere else you want to go? What I mean by that is anything else you want to talk about from for the test? Yeah.
For the 2A, since it's adding it, do I just take like terms from each parentheses and add them together?
Yeah, exactly.
And the same for subtracting them?
So for B, the only difference between 2A and B, when there's a plus in there, does that change anything inside? No.
Oh, you have to distribute.
So I didn't have to worry about the parentheses. I can just start putting stuff together. Part B, I've got to take that negative through.
And distribute it and then do the
And
like
then
terms?
put stuff together.
Okay.
Yeah.
So that just changes the sign.
Do you have a sleepboard?
Yes.